Oh, hi. Let's begin. Parts of Quadratics. Here we go. It'll change. There we go. So, vertex form. Actually, quick note, best idea, pause this, write down the things that are new to you, which all of this should be pretty much review at this point. But then listen to this part. The thing that's really the most worth listening to is note that the H value changes signs. A lot of times in class today I saw y'all giving me the wrong sign for your X value. So because it says X minus H, that minus sign is changing the sign of your vertex for just the X value. So just take note of that. Otherwise, all the rest of this I'm pretty sure we wrote down in our foldable today. So again, here's another example. And in this example, again, note that the 3 here changed to a negative 3 here. Otherwise, everything else from here is pretty basic. X equals negative 3 because that's the X value of the vertex. Minimum is negative 2. It's a minimum because the A value is positive. A is 1/2 here. Doesn't matter that it's a fraction. What matters is that it's positive. Domain and range never change, or domain never changes. Range, because we have a minimum, is negative 2 to infinity, and because A is positive, it opens up. Well, that's all good and fine, but let's take a look at how to graph something like that. So, yeah, we just said that the vertex, and I'm pretty slow, so I forgot. Oh yeah, negative 3, negative 2. The vertex is negative 3, negative 2. And so we go there, 1, 2, 3, negative 2, 1, 2. Okay, so there's my vertex. And well, now at this point, what we need to do is we need to make a table. X, Y, and in the middle of your table, you need to put your vertex. And then you need the points above and below that. So above that would be negative 4, negative 5. Below that would be negative 2, negative 1. And we're going to fill in these numbers here. Now, here is a nice little trick, and this is actually going to be an answer to one of your WSQ questions. The trick here is you can use the A value to generate the next point above and below the vertex by just adding or subtracting that A value to your vertex. You add it if it's positive, you subtract if it's negative. So I have 1/2, oh darn, it's a fraction, decimal, whatever, doesn't matter, okay. It's positive, so I'm going to add 1/2 to negative 2, which is negative 1.5. And so that's going to be that number both above and below my vertex. Again, that's an answer to your WSQ question. You add or subtract the A value, and that only works for the first point above and below the vertex. So then that's going to be right here and right here. Okay. I'm going to get one more point, then I'm just going to have to plug it in to find it the old-fashioned way. So I'm going to take the smaller of the 2 points, I'm going to plug it into the X up here. So then that is F of negative 1 is 1/2 of negative 1 plus 3 squared minus 2. Negative 1 plus 3 is 2. And 2 squared is 4. Half of 4 is 2. And 2 minus 2 is 0. So then on this, we get 0. Is that right? Yeah, it's good. Okay. So then that means we're going to have this point here and this point here. Okay. And since I have 5 points, 5 accurate points, now I can sketch this graph, which will look something like this. Okay. Again, pause this, write it down if you need to. Otherwise, a thing worth mentioning on standard form, okay, most important thing is negative b over 2a. You have to figure out what negative b over 2a is, but watch out for double negatives. There's an example like that in the foldable today, and still I saw people when we were practicing on the whiteboards mess up on the double negatives. So if b is negative, you're going to have a double negative on top. Just, you got to be looking for that. Alright, and what you're doing here is you are figuring out what negative b over 2a is, and just for the sake of simplicity, let's say it's a simple number like 3. And then you're going to take that number, again, let's say it's 3, and you're going to plug it into the x value of your function. Okay, you'd replace the x's with 3 or whatever it happens to be. That's what this is saying down here. Okay, the vertex is negative b over 2a is the x part, and f of negative b over 2a is the y part. The f is what makes it talk about y values. Negative b over 2a is saying you're plugging in that number to get the y value. And all that is still pretty darn confusing, so seeing an example will help. Oh yeah, and all other parts are found the exact same way as before, so that's nothing new. So then we look at the example here, and I've got x squared plus 6x plus 5, so we want to identify a is 1, b is 6, c is 5. Now, negative b over 2a, first thing you got to do. B is 6, so I've got negative 6, no double negatives, yay. A is 1, 2 times 1 is 2. Negative 6 divided by 2 is negative 3. Okay, that's the x value of my vertex. But now I'm going to take this negative 3, I'm going to plug it in anywhere I see an x. Which that's what we see right here. I plugged in negative 3 to the x here, and I plugged in negative 3 for the x here. Square that, you get 9. 6 times negative 3 is negative 18. And subtract all that mess and you get negative 4. So the vertex is negative 3, negative 4. And from that we just find axis symmetry the same way, max min the same way. It is a minimum because again the a value is positive, so it is a minimum, which then affects the range, minimum to infinity, negative 4 to infinity. And the only thing that's different on standard form is I can easily tell the y-intercept, which we're going to use that to our advantage here in a moment. So, okay, again, the vertex was negative 3, negative 4, alright. Now, how to graph that, let's put our negative 3, negative 4 on there. Negative 3, negative 1, 2, 3, 4. Okay. The other point I'm going to go ahead and put on here is the y-intercept, which was 5. So 1, 2, 3, 4, 5. Okay, then let's make a table again. And my table, I've got, I've got in the center was negative 3, negative 4. And then off to the side, well, let's just do this here. We got 2 above, which is, and 2 below. Negative 2, negative 1, negative 4, negative 5. And I'm actually going to do something a little bit unusual. I'm going to go one further because we already have this little point right here. I have 0, 5. So I'm actually going to go 1 back this way and go to negative 6 and call that 5 as well, because it's a kind of a freebie point, really. I can see that 3 points after negative 3 is 5, so 1, 2, 3 points before is also 5. So using that, I get this point right here. And I really only want 5 critical points anyway. They don't have to necessarily be all 5 points in a row. So what I'm telling you here is that you can use the y-intercept as one free point. and then I can use my same trick with the A values as my other free point, and really I don't have to do any heavy-duty calculations. So if the A value is 1, then I'm going to add 1 to my vertex point, -4 here. -4 plus 1 is -3. So then that's going to be right here and right here. Meaning that I have enough points now to draw an accurate graph, and I didn't have to plug anything in, which was nice. So this is how I graph it. Yeah, that's it. Go back and re-watch any part that you need to. Make sure you took notes, complete the WSQ, and have a great day. See you tomorrow.